Okay, so we're on to Chapter 13, Dealing with Errors. On this front slide, there are three kinds of errors I think you need to know about. One, where you're not following the rules of the language, that's the middle line. Another one where you're not following really the right process of doing things, the right thought process. And another one that would be an error that you'd see when you ran the program. Really, you want to create a file, then open it, and then append it. Otherwise, you're going to get problems. And don't forget about the quote on the open readme.txt. GCSE, I think there are three kinds of error that you need to know about. It's not explicitly in the exam specification, other than just saying that when you program, you've got to be able to deal with errors, but I think there's three types that you need to know about, and occasionally there's a question about this. First one is the syntax. That's a syntax error where you're not following the rules of the language, spelling things wrong, for example. Other type thing you need to know about is the runtime. So you don't actually get an error message while you're coding, but when you run it, something happens. It might be something may not happen, but there'll be some kind of error message that only occurs when you run, or some kind of error that only occurs when you run. Logical, there's something wrong with the thought process here. Very similar to runtime, you're not really going to get an error message as you're coding, but you'll then run your program, you'll get unexpected results and wonder what's going on there. Syntax errors is where you're not following the rules of the language, like we said, like a spelling mistake, or things like you're not got the right number of brackets, so you might have two open brackets, only one closed bracket, or you might have opened a quote but not closed a quote, that kind of idea. Look at this. You know that print hello world should print hello world to the screen, but still you've got an error message here. The first line saying about a traceback, fine, you can kind of ignore that. Next one's telling you where the program is and what line it happened on, then the next line after that is what line that happened on. Finally, you have something which is a bit more useful for you. You've got a name error here, and it's saying that name print is not defined. Well, print should be defined. You know what print is. But look a bit closer. Print, capital P, is not the same as print, lowercase p, and there's your problem. So you can reduce syntax errors by looking really first and foremost at the editor itself, because it will highlight if there's an error. When you run it, it should highlight the particular line or the line before that there's a problem with. But there are some simple rules you could follow. For example, watch your brackets. If you open some brackets, make sure you close it. It should be the same amount of open brackets as there are closed brackets, and vice versa. And exactly the same with speech marks. If you have one single quote, you want another single quote to close off the string that you're defining. Watch your operators. Assign is a single equals, double equals is the same as, or the equality operator. Common thing I see when I'm teaching if statements is people use one single equal instead of two equals when they're trying to compare something, and it'll pop up a syntax error. In some languages it won't even do that. It'll just go, well, are you able to assign the string Gandalf into the variable name, and if you are, that will then evaluate as true, so it would head on through your true clause. Another thing to think about is your indentation. Make sure they align properly. The first example at the top there, for some reason the coder has indented in the else clause of the if statement, and that's going to give you an indentation error. The bottom example there is how you should be doing it. Align your if and else, align your two print statements. Watch your indentation. Now, have a go at sample code 13.6, problems to fix. What it's got here is the previous code from the previous slides with 5 errors altogether to fix. Have a go at that, pause the video, and I'll give you the answers in a sec. So here is the answers. There were 5 to find. The first problem was the brackets weren't closed. The next problem was the speech marks weren't closed. The next problem was the operator. It should have been a comparison operator, not the assignment operator, so double equals. And the last 2 mistakes were the else clause needed to be aligned with the if, and then the print needed to be shifted back over to align with the print above. And there's your 5 mistakes. Second kind of error is runtime errors. These are hard to spot. As you're coding, you're not going to see anything pop up with any kind of problem. It'll only occur when you run the program. The editor's not going to pop up and tell you where the problem is. Now, looking at this, you've got a subroutine called readFile1. You know it's a procedure because it's not returning anything, and it's opening up a file. But if you were to run that program, nothing would happen whatsoever. So there's a problem with a runtime on it, and there's an error to fix on that. Now, the other error to consider is, imagine shopping.txt wasn't there when you try to open up and read in. What would happen then? Well, you try, open up 13.9. Here it is here. First mistake is to try and get it to even run the read file. And then once you've done that, it should then call read file, but there will be a problem. There'll be an error message, and you need then to try and fix that. But the clue's there in the red tasks below. Have a go, pause the video, I'll show the answer. Here's the answer. First problem was we're calling read file 1, but you need brackets as a subroutine. You've got to tell them what parameters is needed to run this subroutine. Otherwise it won't do anything. And the second problem was there was no shopping.txt file, so change it to shopping2 and it'll actually find that text file that should be there and it'll open it up. Simple rules to follow for runtime errors really is as you go along, just test it. Test each little piece as you go along. For example, if you're opening files, test that little piece in isolation. Does the file open? Can you read it? Another one that I use quite a lot is when you run into problems, use the print statements. Pop print statements all throughout your code to see what exactly the variables are, what's happening. Put a print statement in a particular part of the code to see if you actually even got that far in the code. And the other one's quite obvious is go through your code carefully. And what's not written there is, if you have somebody who's a programmer friend or colleague, get them to look at your code, explain to them what's going on, and you may find as you explain it, you'll realize where the mistake is, or they'll spot and go, hang on, you should be using insert solution here. Final type is the logical errors. This is something to do with thought processes, your order of doing things. You haven't quite thought this through. You might have missed out some bits and bobs. Commonly I see it as BODMAS and BIDMAS with calculations, not realizing the order of doing operations. And like the runtime errors, you're not going to get any obvious error messages. In fact, it's even worse than the runtime error because you won't even get an error message pop up. It will just give you the results, your output that you want. And then you'll think, hang on, that's not what I want. Like if you look at this here, there's a problem with this. Go and have a go at 1311 logical error. Here it is here. Run it. See what happens. Well, first of all, predict what you think is going to happen. Then run it, see what find out what actually happens. Then use a calculator. Work out the mean of 12, 15, and 18. Is the answer that it tells you, is that the correct answer? Then can you try and fix that yourself? And the hint really is BODMAS or BIDMAS. Pause the video, and I'll show you the answer in a second. Here's the answer. All you have to do is put some brackets around the addition. If you know BODMAS, BIDMAS, it would have done this calculation first, the division part, because that comes before addition, which is why you would have got a weird answer. The final part was to make the program a little bit more useful in that you could add any number of scores and it would give you the mean. Now the way I did that was to use a repeat until loop, a while true, and break out of it, but you could have done another way with a while loop. But there you go, so all I did there was set the count and total up, set a while true, so that'll go on forever until I break out of it. Ask for a score, just check the score is what I want, make sure it's not a negative number. Then add it to the total, then add it to the count, and then eventually, once I'm happy, break out of it, and that'll then give me my mean just using a format. But you could have done it a different way. Reducing logical errors is very similar to the runtime errors. Pop in some print statements to see where you're going, pop some print statements in the different parts of the code to make sure you get to those points in the code. Again, test it separately, little pieces by little pieces, just to see where the actual error message is. And a good one for calculations is a trace table. That's why we teach you these things. List your variables, go through manually step by step to see which bit is what. Now bear in mind also, you can add breakpoints into your code that allow you to inspect variables as you go along. I'll show that in more detail at a later time. So what have we learnt today? Okay, 3 types of error I told you about. The one we don't follow the rules, the syntax. The one where the error message occurs when you run. And the final one is there's no error message at all, but you're getting results that you don't expect. You know how to get in contact with me if there's any problems. Let me know. Cheers.